think I'm here because I really like bumblebees. I want to be able to provide a scientifically based answer to if bees are exposed to dangerous mixtures of pesticides.
I think it was very interesting for me to have information about exposure of bees to chemicals and have this discussed from different perspective how we can gather this information and what can we do with this information then while testing mixtures or implementing models. That was a very interesting thing.
We have a series of good models that allow us to predict and assess the toxicity of mixtures on the basis of the knowledge of the toxicity of the individual compounds. But what we need to have is that knowledge. So we need to understand how the different pesticides work, how toxic they are, to which life stages they are toxic, in order to run and apply the models that we're having.
The most interesting part of my research was actually to understand whether we could model chemical mixtures data in order to provide reliable and robust models, so QSARS models. We know that in the literature there are many QSARS models for single chemicals, but so far few articles were published on mixtures toxicity, and in bees to date there are no articles published investigating the combined toxicity. So I believe that I could bring to you some good news.
What I found most interesting was to think about mixtures being all around us and thinking of ways that we can really define exposure, particularly in the context of bees, and how we can relate that exposure to effects. And I enjoy talking about the bumblebee population models that we use as a way of understanding how exposure in the landscape links to population level effects.
I have a much better understanding of the possibility to predict effects on bees based on chemical mixtures. I wouldn't say that I understand everything, but I have a better understanding of the different types of approaches you can take.
I learned that it's possible to predict combined toxicity of a pesticide using QSAR for contact toxicity, so that was really interesting to be introduced to this new model.
I became aware of different ways to combine toxicity information on individual compounds and how to combine that into a mixture effect, and that there were different ways of doing it, and that sometimes these different ways coincided with each other, and sometimes one was more conservative than the others. So that was very hopeful because in a sense then we could actually use experimental data on individual compounds to do mixture assessment.
I think it's problematic in one way because bees can select the flowers they forage in, and there is also this accumulation in the colony that can have also a different degradation pattern, and that makes it very complicated, most from the exposure way, compared to, for instance, fish that maybe don't select the water they are living in so much.
So for the bumblebee population models to be used in chemical risk assessment, we would need to properly define exposure, both spatially and temporally, and then understand how that relates to colony level effects. And that's hard for us to do because we don't have a explicit pesticide module in our bee models. So at the moment, pesticides can't accrue in any way, and we can't define dose response curves. So I guess that would be the most important step for us to be able to do, to define exposure and how that translates to colony level effects.
Pesticides in the environment by looking at residues in water and in air, but we don't have a monitoring system in terrestrial environments, and bees could be a way of sample in the environment, the terrestrial environment.
So I think we are at the moment in a position where we have a lot of models for assessing mixtures in place. What we need is more solid data to apply it to certain scenarios. So for me, one of the take-home message for this particular workshop was that, or not a take-home message, but more a take-home challenge, is to take the knowledge that we have and to apply it to assess the combination effects of pesticides on bee health. And given that we are so critically dependent on pollination, given that we know that they are exposed to mixtures of pesticides, I think this is a really important task for the project that you're starting here now.
And another thing is that we were discussing how to use predictive modeling, for example, quantitative structure-activity relationships to predict mixtures. And here I am still thinking like, what do we need in that term? Should we use still QSRs for individual compounds and then combine them, or should we use QSRs developed from mixtures? That is a question, and we are looking into this.
We have to eat and drink as much as possible different food and beverage in order to dilute the different exposure and the different chemicals contained in the food items. So variation of the diet is I think is the best way to prevent chemical mixtures exposure and effects.
So the systematic review approach is a way to look into literature with less bias as possible, setting up a list of criteria and to select articles that will be then included and discussed with the quality and the relevance of each study being assessed in a systematic and transparent way, in a way that all relevant information are taken into account, and putting all together to have an overview that would be the most exhaustive and unbiased as possible. So that's time and resource demanding way of looking into literature, but it's also the one that may provide very useful information for the community, the scientific community in a broad sense, including regulators, to improve knowledge, identify data gaps, and provide new direction for research, hopefully. So I'm currently reviewing the combined effect of pesticide on bees. So we look more specifically, we test the hypothesis that pesticides with different mode of action would have additive effect on bees. So that's the only way a regulator can deal with mixture at the moment is to assume they have additive effect. But in case of pesticide, it has been a lot focused on synergistic action, which is a bit, I think, biased the research on this topic. So with this review, we want to focus on what can we say about additive effect on bees. How much do we know? How much could we say with what we have already in the literature, and what would be the need for a better understanding on additive effect in bees?
Well, the take-home message is that we should have assessed chemical mixtures a long ago. There was a paper published, was it 1928?
26.
On a chemical mixture model, and I'm just asking, why haven't we done this earlier? Well, one reason could be that we now have the methods, the models, and we have seen the need for this type of assessments. And so in general, doing assessment one chemical at a time, that's past, and in the future it's a combination effects of an exposure effects of chemicals.
I'm totally convinced that we will change the way we assess pesticide risks in the future. I think that we already are on the threshold of doing that. We just need to figure out the best approach to do it, or the multiple approaches to do it.